This video, we're going to talk about supplemental examples from 8.8, which covers the topics of improper integrals. Let's go ahead and look at this first one, explain why the integral is improper and determine whether it diverges or converges, evaluate it if it converges. So it's improper because it has behavior that's asymptotic, that's going towards infinity or negative infinity or both. As I get close to x equals 1 from the left, it's going to positive infinity as it gets close to x equals 1 from the right. Also go into positive infinity, so there's a infinite discontinuity there at x equals 1 that I'm going to have to remove by letting this go 0 to b, limit as b approaches 1 from the left of x minus 1 to the negative second dx plus, and then limit as a goes to 1 from the right of a to 3 of x minus 1 to the negative second dx. It's going to be x minus 1 negative first over negative 1 from 0 to b, limit as b approaches 1 from the left, plus limit as a approaches 1 from the right of x minus 1 negative first over negative 1 from a to 3 is negative, limit as b goes to 1 from the left of a negative 1 over b minus 1 plus 1 over 0 minus 1 plus limit as a goes to 1 from the right of negative 1 over 3 minus 1 plus 1 over a minus 1. Just evaluate. Let's look at f of x is equal to a function negative 1 over x minus 1 here. And as I get close to 1 from the left there, so x minus 1 would look like this. But I'm going to have to reflect that. So positives become negative and negative become positive. So this is going to do this and this. And as I get close to 1 from the left, I'm going to positive infinity minus 1. And then this is minus 1/2. And then looking at this piece here where it's positive, and I'm getting close to 1 from the right, I'm also going to positive infinity here. So that is going to give me infinity minus a constant is infinity, and it diverges. All right. Determine whether the following integral diverges or converges, and evaluate it if it converges. So this is related to a p-integral. Remember, theorem 8.7 tells us if we're going from 1 to infinity of 1 over x to the p dx, that it converges to 1 over p minus 1 if p is greater than 1, and it diverges if p is less than or equal to 1. P in this case is equal to 1/3, which is less than or equal to 1, so it diverges. And that's really all that I need to say, but let's go ahead and let's figure that out using improper integrals here. So since we're going to infinity, 0 is my only bad number and it's not in my limits of integration here. So we're going to take the limit as b goes to infinity of 1 to b of 3x to the negative 1/3 dx is equal to 3x to the 2/3 times 3/2 evaluated from 1 to b, limit as b goes to infinity. So this is 9/2 limit as b goes to infinity of b to the 2/3 minus 1 to the 2/3 is 9/2. And then this is infinity to the 2/3 is infinity. Minus 1, so x to the 2/3 looks like this. As I go out to infinity, I'm still going to infinity. This is infinity minus 1, still infinity. Like that. So it diverges. Just like our theorem said it would. Let's determine whether the following integral diverges or converges and evaluate it if it converges. So we're going to need to use integration by parts here. dv is going to be e to the negative x dx. U is equal to cosine of x. So du is a negative sine x dx. And v is equal to a negative e to the negative x. So we have uv minus the integral of v du. Like that is, I'm going to let I equal 0 to infinity, e to the negative x cosine of x dx. Call this side I is equal to, as b goes to infinity, of negative cosine of b times e to the negative b plus cosine of 0 times e to the 0 minus limit as b goes to infinity, 0 to b of e to the negative x sine x dx. So I is equal to so cosine of b has to be somewhere between -1 and 1, but that doesn't matter because this is going to 0. So that whole thing is going to 0. And then I have plus 1 times 1 is 1 minus limit as b goes to infinity of 0 to b, e to the negative x sine x dx. So u is going to be sine x, dv is going to be e to the negative x dx, du is a cosine of x, v is a negative e to the negative x, so I is equal to 1 minus uv is infinity of 0 to b minus the integral 0 to b of v du. I equals 1 minus a negative is plus, limit as b goes to infinity of sine b e to the negative b minus sine of 0 e to the 0. And then you have minus a negative negative, that's still minus 0 to b of e to the negative x cosine of x dx. So all that right there is I again. So I equals 1 plus, and then this here is going to be negative 1 to 1 times 0 is 0 minus, and then that's 0 minus I. So 2I is equal to 1. I is equal to 1/2. So it converges. Alternatively, we didn't talk much about using tables, but you can have 0 to infinity, e to the negative x cosine of x dx. And using our tables in the textbook, we can use table number 86, which says that the integral of e to the ax, e to the au, cosine of bu du is going to be equal to e to the au over a squared plus b squared times a. Give myself some more room here for this. E to the au cosine of bu du, e to the au over a squared plus b squared, a cosine of bu plus b sine of bu. And just sure that's right. So then we can come in here and say A is a -1, B is equal to 1, and this is integral of e to the negative x cosine -1x, and it's cosine of 1 times x dx is e to the negative x over -1 squared plus 1 squared negative cosine of x. This is going to be all evaluated from 0 to infinity here. Negative cosine x plus sine x. Again, evaluated from 0 to infinity. And that would give me -1/2 e to the negative x cosine of x plus 1/2 e to the negative x sine x. Limit as b goes to infinity, 0 to b, and then you can evaluate that, and like we did up here, comes to the same point. You're going to get this is equal to 1/2, and the text is going to use this tabular method, looking up things in integration tables. Moving forward, it'll just evaluate difficult things like that. It's not going to use integration by parts like this every time moving forward. Just look it up in the table. All right. Determine whether the following integral diverges or converges. So u is going to be ln of x, du is going to be 1 over x dx, n is a -3, and do a u substitution here. This is going to be ln of 4, and ln of infinity is still infinity. U to the -3rd du, like that, is going to be equal to limit as b goes to infinity, ln of 4 to b, u to the -3rd du, limit as b goes to infinity, u to the -2nd over -2, from ln of 4 to b, limit as b goes to infinity of -1 over 2u squared, from ln of 4 to b is a negative, is equal to a limit as b goes to infinity, a -1 over 2b squared plus 1 over 2 times ln of 4 squared is 0 plus 1 over 2 ln of 4 quantity squared is equal to 1 over 2 ln of 4 quantity squared. So it converges. All right, that's it for this video, and that's it for supplemental examples for chapter 8. We'll come back next time and talk about supplemental examples from 9.1. See you for the next video.